Here is the solution for question 19. Nikki is driving a motorboat across a river that flows at 5 meters per second. The motorboat has a speed of 12 meters per second in still water. She heads out from one bank in the direction perpendicular to the current. How far does she travel in 3 minutes? So that's the question. So let's try to understand the situation, right? Let's say this is the river, right? And let's assume that the flow of the river is in this direction, correct? Now, we'll use different ink to show the heading of Nikki. So Nikki is driving a motorboat across a river that flows at 5 meters per second, right? So this flow is 5 meters per second. So this is, in this direction, 5 meters per second. The motorboat has a speed of 12 meters per second in still water. And she heads out from one bank in the direction perpendicular to the current. That means she is heading out like this, in this direction. Do you see that? And the speed is 12 meters per second. So it is 12 meters per second in this direction. How far does she travel in 3 minutes? So that is the question. Now the important thing here is, note the units. Speed are given in meters per second and time here is given in 3 minutes. So we need to convert minutes to seconds, right? So that you could directly apply your formula. So otherwise you could make a mistake. Now let's make a position diagram here. So as Nikki heads out, she moves like perpendicular. The river is going to push her downwards, right? So river is going to push her downwards. So that means if she moves 12 meters per second here, then the river is going to move her downwards with a speed of 5 meters per second. Do you see that? With the result, she's actually not going to go perpendicular direction, right? She will not go directly across. She will actually land somewhere down like that. So that becomes the resultant. You see that? That's the resultant. So that is why in whatever duration of time it is, she is traveling because of her speed in the horizontal direction plus because of the river speed in, you can say that, vertical direction going downwards. Okay? So that is the case. Now since she is heading at 90 degrees, this angle between the two is 90 degrees. Now if you make your vector diagram, right, which is kind of shown here to you, in that case, in the vector diagram, the two sides will be in the ratio of 12 and 5. You see that? They will be in the ratio of 12 and 5. Therefore, you can find what R is using Pythagorean theorem, correct? So, and that will be per second. So if you multiply that with 3 minutes, then you get your answer, right? So basically you should say that river velocity, or we say velocity of river, is 5 meters per second. Velocity of boat is 12 meters per second. And time we're talking about is 3 minutes, right? Which you should convert. So which is 3 into 60 seconds. So that is your time, correct? Now if you see in 3 seconds how much distance will they cover, so we can do it in per second and then multiply by that time. That is perfectly fine. So let's first find relative velocity. So I used R for river, so I will not use this resultant R. Okay, otherwise that's going to, let's use water, W for water, right? So R will use for resultant. So V resultant will be equals to square root of boat velocity square plus water velocity. It's like a Pythagorean theorem solution. Do you see that? Actually there should have been, if the triangle is not right angle, then we'll have a component of 2ab cos theta, right, with minus sine. But in this case, this angle is 90 degrees, so we are not really considering cos of 90 is 0, right? That is the reason. So we can find the resultant velocity from here. So which is, in our case, 12 square plus 5 square. right? So that gives us the resultant velocity. Let's find that resultant velocity also using calculator. So 12 square is 144, we know it, but anyway, we'll use calculator, okay? Plus 5 square, which is 25, we know, and we'll just add them. It is 169, and then you do square root of 169, and you do get 13, which was expected. So we get 13, and the speed is meters per second. Why I've done this step? Sometimes we are also asked about the resultant speed, right? In this question we are not asking. Now we know now speed. Now we need to find how far she travels. Distance, right? So distance is relatively, distance will be speed into time, right? That is from our triangle, which we know velocity. We'll use this triangle now. So this triangle gives us distance, speed and time, right? So distance from here is the resultant velocity Vr into time t, right? So in our case, the resultant velocity is 13, units are meters per second, times time is 3 times 60 times seconds. You see, second and second cancel out, and you get your answer. Do you see that? So that is how you'll get your answer, which is 13 times 3 times 60. And that gives you 2340. So we can always write this answer in meters. 2340, I mean this is in meters, but we should write it in kilometers, which is 2.340 kilometers. So that is the distance which she travels, right? At times they may also ask you downstream. What distance downstream did she reach? Right? There could be different kinds of questions. But in this question, so the distance traveled in 3 minutes is 2.34 kilometers, right? So that is how we'll answer this question. But I hope you understand the concept. Thank you and all the best.